In this video, we want to learn about the sum and difference identities for trigonometric functions. Also, we want to learn how we can use these identities to simplify expressions involving trigonometric functions. And also, we want to prove other identities. Here you can see a list of identities for sine, cosine, tangent that involve sum and difference of two angles. Sine of A plus B is sinA cosine B plus cosine A sine B. And if between A and B we have minus, then in the other side between these two terms we have a minus. Let us start with this first example before we look at the other identities that here we have. Let's see how we can use the first identity to simplify this expression. Sine 27 times cosine 33 plus cosine 27 times sine 33. By looking at this expression and comparing that with this expression here, we can see that this completely matches with this. Sine cosine, sine cosine, then cosine sine, cosine sine. And of course this should be AB, AB. So everything matches between this expression and the right side of this relation. From this identity, we know that we can write this as sine of the sum of these two angles. So based on this identity, we know that this equals sine of. So we want to use this relation, but not from the left to the right. We want to use it from right to the left. We want to write this in this form. So by using the first identity that here we have, we can write this expression in the form of sine of A plus B. The A is 27, the B is 33. So sine of 27 times cosine 33 plus cosine 27 times sine 33 is sine of 27 degree plus 33 degree. But we know that 27 plus 33 is 60 degree, and sine of 60 degree based on the special triangles that you should be familiar with, sine of 60 degree is a square root of 3 over 2. Let me remind you this important triangle. Here is 30 degree, 60 degree. Here is the square root of 3, here 1 and here 2. Sine of 60 is opposite over hypotenuse. Radical 3 over 2. So sine of 60 degree is radical 3 over 2. So with the aim of this identity, which is the sum identity for sine, we could simplify this expression. Attention, we don't know what is sine of 27, what is cosine of 33. We don't know values of any of these, but we could simplify this because we use this relation. We simplify this to sine of 60 degree, and sine of 60 degree is radical 3 over 2. Now look at the next example. Cosine 80 cosine 20 plus sine of 80 sine of 20. Here, if you notice, we have cosine times by cosine, cosine times by cosine, minus or plus sine sine. So this matches with this identity. But attention, here we have a plus. In this identity, which is for cosine, if between these two terms we have a minus, then in the other side is a plus. The sign is basically opposite. And if in the right side we have plus, in the left side it is minus. So if we want to use this relation to simplify this, the answer is cosine of A. What is A? The 80 degree is A, the 20 degree is B. So it equals cosine of 80 degree and 20 degree, but plus or minus. Because here is plus, here would be minus. For cosine, these two signs are opposite of each other. For the sine, these signs are the same, positive, positive, minus, minus. But here, when it's plus here is minus, here is minus, here is plus. So this, for cosine, it's opposite. So because here is plus, you should put minus here. So this equals cosine of 80 minus 20. And this equals cosine of 60 degree. And probably you know that again by the special triangle, cosine of 60 degree is 1/2. So the value of this expression is 1/2. You can check this by a calculator. Now look at the next example. What is sine of 2x cosine x minus cosine 2x sine x? Because these two are not the same, so this should be related to sine. When these are the same, cosine, cosine, sine, sine, it's related to cosine. But when these are different, it's related to sine. So this equals to sine of, but sine of what? A. What is A? The A is 2x. The B is x. What we have to put between? Minus or plus? We know that for sine function, for the sine, when here is plus, here is plus. When it's minus, minus. So here is minus. So we have to put minus between these two. So this equals to sine of 2x minus x. 2x minus x is x. So this equals sine of x. So we simplified this complicated expression, and the answer of that is just sine x. Very simple answer. So we use these identities, of course not this one yet, but we use these two identities to simplify these really complicated expressions, and these are the answers. Let me show you more examples. Look at this first example. Sine of 7 pi over 12 cosine pi over 12 minus cosine 7 pi over 12 sine of pi over 12. This is again related to the sine function, because as you can see, these are different trig functions, sine, cosine. If it was cosine, cosine, then it is related to cosine. But this is sine, cosine, so it is related to the first identity, to this identity here. And so it is sine of, so this equals sine of A, which is 7 pi over 12 minus pi over 12. Why minus? Because here is minus, we have to put minus between. 7 pi over 12 minus 1 pi over 12 would be 6 pi over 12. So this equals sine of 6 pi over 12. But 6 with 12 simplifies, we have a 1 here, a 2 here, so we have sine of pi over 2. 6 pi over 12 is pi over 2. But what is sine of 90 degree or pi over 2? Sine of pi over 2 is 1. Remember the unit circle? This is pi over 2 or 90 degree. Pi over 2 is here. At this point, remember the y is sine. What is the y value of this point? This point, this is unit circle. So at this point, the y value is 1, so this is sine. And x-axis is cosine, the y-axis is sine. Sine of pi over 2 is 1. You should memorize the sine and cosine and tangent of these famous angles. Look at the next example. We want to simplify tangent of 72 minus tangent of 12 over 1 plus tangent of 72 tangent of 12. This relation reminds me this relation here. Tangent A minus tangent B over 1 plus tangent A tangent B. Attention here. When it's minus here, it's plus, and the answer is minus. If here is plus, the other side is plus, the denominator is minus. So, based on this relation, tangent A minus tangent B over 1 plus tangent A tangent B is tangent of A minus B. So we want to use this identity to write this in this form. So by using that identity, this equals tangent of A minus B. The reason that you have to put minus here is because here is minus. If here was plus and here minus, then we had to put plus between the two angles. Maybe you wonder what happens if here is minus and here is minus. Then we have no relation for that, and we cannot simplify that. We can only simplify when we have exactly one of these two cases that here we have. So 72 minus 12 is 60. So this equals tangent of 60 degree. What is tangent of 60 degree? Again, you can use the famous triangle. Here is 30, here is 60, root 3 here, 1, 2. What is tangent of 60? Tangent is opposite over adjacent. So tangent of 60 is radical 3 over 1 or radical 3. Tangent of 60 degree is radical 3. The value of this expression is radical 3. And you can check this by a simple calculator. Now we want to prove these identities for trigonometric functions. Sine of pi over 2 plus alpha is cosine alpha. We want to prove this relation between sine and cosine. So we want to prove that sine of this angle is cosine of alpha. To prove this, let me remind you which identity we have to use. Of course, we have to use this identity, sine of A plus B. When we have two angles for sine, we can use this identity to expand this and write it in this form. So we want to use this identity for proving this. So let me write the identity here. Sine of A plus B is sine A cosine B plus cosine A sine B. We use this relation. And for using this relation, we start from the left side, which is more complicated, and we simplify that and we get to the other side. So we start from sine of pi over 2 plus alpha, and we expand this with the aim of this relation. This equals sine of pi over 2 cosine alpha plus cosine pi over 2 sine alpha. What is sine of pi over 2? Remember unit circle. Pi over 2 is here. Sine of pi over 2 is 1. So this is 1. Because at this point, sine is the y value of this point. Y value is 1. So this is 1 times cosine alpha. So we have cosine alpha. What is cosine of pi over 2? Cosine is the x value. What is x coordinate of this point? What is x value of this point? 0. Because it is on the y-axis. So this is 0. And this is the end of the proof. We prove this relation. So again, this is 1. 1 times cosine is cosine. This is 0. 0 times sine is 0. So this is gone, and this is cosine, which is the other side. This completes the proof of this relation. Now we want to prove the other relation that here we have. We want to prove that cosine of 3 pi over 2 plus theta is, here should be sine of theta. Probably I erase this. For proving this, we have to use the identity that we have for cosine. Remember, cosine of A plus B is cosine A. Cosine B minus sine A sine B. When here is plus, the other side is minus. By using this identity, we can write cosine of 3 pi over 2 plus theta as cosine of 3 pi over 2 cosine theta minus sine of 3 pi over 2 sine of theta. Now for simplifying this, again we need to know the value of cosine of 3 pi over 2 and sine of 3 pi over 2. This is pi over 2, this is pi, and this is 3 pi over 2 here. This angle is 3 pi over 2. What is coordinate of this point? The x value is 0, the y value is -1. So the coordinate of this point is 0, -1. And remember, this shows the x value shows the cosine, the y value shows the sine. So based on this, what is cosine of 3 pi over 2? Cosine of 3 pi over 2 is 0. But sine of 3 pi over 2 is -1. And -1 times by this negative here would be +1. So we have this expression equals sine of theta. Because this is 0, all of this would be 0. Negative of -1 would be 1. 1 times sine theta is sine theta. And this completes the proof of this identity. Look at the next one. Tangent of pi minus theta is negative tangent theta. For proving this, we need to remember the formula for tangent. Let me remind you the formula for tangent. Tangent A minus B is tangent of A minus B is tangent A minus tangent B over 1 plus tangent A tangent B. So, for proving this, we can expand the left side with the identity for tangent. Tangent of pi minus theta is tangent pi minus tangent theta all over 1 plus tangent pi tangent theta. Tangent of pi is 0 minus tangent theta over 1 plus tangent of pi is 0, so all of this would be 0, so plus 0, and this equals negative tangent theta. Let me tell you the reason that why tangent of pi is 0. Pi is here, probably you know that this is pi or 180 degrees. The coordinate of this point is -1, the x is -1, the y is 0. 1 unit to the left, -1, and y is 0. Remember, tangent of pi is sine of pi over cosine pi. What is sine of pi? Sine is y value. The y value is 0. Cosine is x value. 0 over -1 is 0. So this is 0, this is 0. So we have negative tangent theta. This completes the proof of this identity here. The other way that you can prove this relation here is to remember that the tangent can be written as sine over cosine. So you can write tangent of pi minus theta as sine of pi minus theta over cosine. Then you can expand this like I did here. You can expand the denominator like I did here. Then you simplify numerator, simplify the denominator, divide them, and finally you can get to the other side. But it would be a little more complicated, but it works. You can try that way also. Now look at these relations. We want to prove that sine of alpha plus beta plus sine of alpha minus beta is equal to 2 sine of alpha cosine beta. By looking at this and these angles, we can see that in front of sine we have two angles. In front of sine we have two angles. So it should be clear that we have to use the sum and difference identities for sine. So we start from the left side, we expand this, and we try to get to the other side. By using the identities that we have for sum and difference for sine, we can write sine of alpha plus beta plus sine of alpha minus beta as this is equal to sine of alpha cosine beta plus cosine alpha sine beta. For the next one, we can write sine alpha cosine beta minus cosine alpha sine beta. Now if you attention, this term with this term cancel. What remains? Sine alpha cosine beta, sine alpha cosine beta. So it's 2 of that. So this equals 2 sine alpha cosine beta, which is the other side. And this completes the proof of this relation. The proof of the next identity is very similar. We expand this and we write this as cosine alpha cosine beta minus sine alpha sine beta. You know that for cosine the signs is opposite. Here is plus, here is minus. For the next cosine, for this one, we have cosine alpha cosine beta plus sine alpha sine beta. This cancels with this. What remains? It remains 2 cosine alpha cosine beta. We have these two terms, they are similar, so we have 2 of them. And it is the other side. And this completes the proof of this identity. Now look at this relation. Sine alpha plus beta over cosine alpha cosine beta is tangent alpha plus tangent beta. Here we have a trigonometric function sine with some of the angles, 2 different angles. So we think to using the identity that we know for sine of a plus b. So we expand the numerator. By expanding the numerator, we have sine alpha cosine beta plus cosine alpha sine beta. This is for numerator. And we leave the denominator cosine alpha cosine beta. Now look at this. We have 2 terms in numerator which we have to divide by the denominator. If we divide this by this and we divide this by this, we can get to the other side. So we separate numerator over denominator. Then we have sine alpha cosine beta over cosine alpha cosine beta plus this term over this term, which is cosine alpha sine beta over cosine alpha cosine beta. Now if we simplify, the cosine with cosine cancels and we have sine over cosine, but we know that sine over cosine is tangent alpha. For the next fraction, if you pay attention, cosine with cosine cancels and we have sine beta over cosine beta, which is tangent beta. And this completes the proof of this identity. Here we have a little more advanced example that we want to prove. We want to prove that cosine alpha minus beta times cosine alpha plus beta is equal to cosine to the 2 alpha minus sine to the 2 beta. It should be clear that we have to start from the left side. Why? Because it's more complicated. Usually we start from more complicated side and we try to simplify it with the identities, algebraic relations, other things to get to the other side, which is simpler. So we start from the complicated side, which is the left side. For the left side, it should be clear that we have to use the sum and difference identities for cosine. So we start from the left side, cosine alpha minus beta, cosine alpha plus beta, and we expand this. Cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. This is for the first cosine. And remember, when it's minus here, here should be plus. For the other cosine, we have cosine alpha cosine beta minus sine alpha sine beta. If you look at these two brackets, they are exactly the same but with opposite sign for the middle terms. We have a plus b times a minus b. This should remind you this important identity. A plus b times a minus b is a to the 2 minus b to the 2. Probably you remember this important identity. A plus b times a minus b is a to the 2 minus b to the 2. So this equals cosine to the 2 cosine to the 2 a to the 2 minus b to the 2, which is sine to the 2 sine to the 2. So we use the identity. A plus b times a minus b is a, all of a to the 2, b to the 2. A to the 2 is this, b to the 2 is this, and the minus between. We are a little close to the other side, but it seems that we have to do something with this to get to the other side. Cosine to the 2, cosine to the 2, sine to the 2, sine to the 2, but what we have to do with these things here. So here, let's try using one of the Pythagorean identities. Let me remind you, the most important Pythagorean identity, sine to the 2x plus cosine to the 2x is always 1. From this identity, cosine to the 2 is 1 minus sine to the 2. Simply move this to the other side, then cosine to the 2 is 1 minus sine to the 2. Here, I want to replace this cosine to the 2 with 1 minus sine to the 2 beta. So here I want to substitute the cosine to the 2 beta, so we leave the cosine to the 2 alpha here, because in the other side we have this, and I want to substitute this with 1 minus sine to the 2 beta. Maybe you wonder why I am thinking to this, why I think this substitution works. I told you this is a really challenging example, but the reason behind this is that I know that I want to have cosine to the 2 as a single term, but if I have cosine to the 2 times by this, so instead of this, if I had 1, then 1 times this would be exactly this. For that reason, I remember that cosine to the 2 is 1 minus sine. Now 1 times by this at least would give me this term. I know I have another term, but let's think about that later. So let's continue. And I leave this term here, minus sine to the 2 alpha sine to the 2 beta. So we have cosine to the 2 alpha, multiply this in the bracket, then cosine to the 2 times by sine to 2 minus cosine to the 2 alpha sine to the 2 beta minus sine to the 2 alpha sine to the 2 beta. Now here, at least we have one term here that is the same as the other side, but we have these two terms that they should be this. If you pay attention, these two terms have this as a common factor. If we factor this from these two terms, then probably we can finish the proof of this identity. So we leave this term here, and we factor a negative sine to the 2 beta from these two terms, this term and this term. By factoring that, what remains from each term? Attention, we factor the negative also, negative sine to the 2. What remains from the first term? Cosine to the 2. What remains from the second term? Sine to the 2. Cosine to the 2 plus sine to the 2 is 1. All of this is 1. 1 times by sine to the 2 is sine to the 2, and this finishes the proof of this relation. Cosine to the 2 minus sine to the 2 beta. We started from the left side and we got to the other side. So we proved this complicated identity using the sum and difference identities, and of course other trigonometric identities we used here. I hope by watching this video now you are more familiar with sum and difference identities for trigonometric functions. If this video was helpful for you, please subscribe in my channel and see you in the next videos.